So now, in this video, we're going to go over what I put on this diagram here. So this diagram is really a summary. I started a web page for this series of videos. I'm going to put them into a playlist. So this is going to be kind of a beginner's electronics course. And we're going to break it up into circuit fragments. And so circuit fragments are really parts of circuits that you find all over. So for this video, we're going to look at the resistor. So that's kind of the most basic circuit fragment is the resistor. Sometimes it limits current, sometimes it says voltage or whatnot. So in this video we're going to look at how it limits current. Also, we have to be aware how much heat it is generating, the power generation. We will get to that later. So now, really quickly, since this is going to be the first video of the series, I want to talk about how I'm going to be powering this. So mostly I'm going to be using 5 volts, but I'm going to be using this unit where I can adjust the voltage and limit the maximum amount of current. And this is what I normally use in my videos, now that I have one. But these breadboard power supplies are really common, so I'm going to mostly assume you're using one of these. But these power supplies aren't terribly expensive either. There's larger versions, but this one works good for the camera. So we're going to measure voltage, and we're going to use a multimeter. So I'm not going to use the autoranging meter for this video. I will in future videos, but this one there's a range. So if you're new to multimeters, if you see a bunch of numbers here, that means you have to set it to, in the case of voltage, a higher voltage than what you plan to measure. That will help protect the meter and make sure the probe is inserted into the right spot. So that's voltage and ohms. When we measure milliamps of current, we'll have to move it with this meter here. So some meters you have to move it, some meters you don't. Now, these breadboard power supplies, as I said, are common. Here's the other side of those jumpers there, the probes. And so this is set right now to 5 volts. You can do 5 volts, 3.3 volts, or 0 volts at one rail or the other. As I said, these are common. There's a barrel plug up here, and it comes to this adapter here, AC to DC adapter. And you can set the voltage. So I put 9 volts there. I really like this Soul base supply, and so I link that and this power supply when it's in stock in my Amazon shopping page. If you click the links there and buy products that I recommend on there, I get a small percentage on mini sales. This Lyumi multimeter has been upgraded, and so they upgraded it right after I bought it, of course. But I really like this, but the upgraded version does look better. So in any case, check it out. So we measure the voltage there. This power supply I set to 5 volts, and same voltage we have of that, and I limited current. And so again, we can just measure the voltage of power supplies directly. So the meter does a good job of limiting current through it to protect it, as long as you set it to the right voltage setting. So now, the resistors that you commonly use are called through-hole. They got wires, and you can buy all kinds of kits and stuff. Their resistance value, which is in ohms, we're going to look at how to measure that, is often listed on there. So this actually uses R for resistance, but this is a 220 ohm resistor. And once you learn the color code, you could read it from the resistors there. And so the beige ones I have come in nicely marked packages. That says 10 there. It's 510 right there. And there's also 1K. So that's kilo ohm. So that's 1,000. Wherever you see K, that's 3 more zeros. So in any case, you can read the color code like that. So that's a 1 kilo ohm. So this is a 2,200 ohm. On the blue one, it has 5 stripes. So that's red, red. The red's faded there though. These are cheap resistors, and so a lot of them, their coloring is not perfect, but I got a lot of value. So there's a 220 ohm with the beige resistor, and a 1 kilo ohm and 2 kilo ohm, 2,000 ohms. So that's another thing. Some kits have slightly different values than others, and some of them have a lot wider range of values than others. So let's get the light back to a better position. You can read the color code as we saw there. Again, these have 5 stripes, these have a 4, and then there's a gold stripe there. That's the tolerance. There's a brown stripe on those. These can be 5% higher or lower than their rated value because it's hard to make a perfectly accurate resistor. These ones, it's a brown stripe which stands for 1 in the color code. It can be 1% higher or lower. So now the meter, again, it's not auto-ranging, and so we have a couple, we have one 2.2 kilo ohm, 2200, so that's more than 2000, so we want to set it up there. And then the other one is 2000 exactly, so it may be a good idea to put it up there. And we got the omega symbol there, so we know it's in the right spot. I have to hit the power button now, and it's saying out of limit because the probes are not touching anything, so there's just tons of resistance. And my body is let's go to 20 mega ohms and see there you can see the resistance in my body there. So that's millions of ohms right there. So this is a range meter. You have to go to a range. You cannot damage this while measuring resistance. If you go too low, I think it will just beep or just say out of limit probably. So let's try this. So yeah, it just keeps saying out of limit. That was a higher value one. So in any case, let's get right to it. So 20 kilo ohms and or less. And polarity does not matter. You can put it to either side of the resistor, but just like as you can see on here, you put the meter across it. And do not have power going through the resistor when you measure it. The meter provides all the power, so you want to make sure that one side or the other is not connected to anything else. And there you can see it's slightly less than 2.2 kilo ohms. So that is tolerance. Since these are all less than 20 kilo ohms, we could keep measuring like this. So when you set it to a higher range, it's safe to measure lower ranges. So there you can see 0.22 kilo ohms, which is the same as 220 ohms. Up here is the 2 kilo ohm for the beige right there. Looks like it's a bit higher. It'll be more accurate the closer you are to the setting though. So we'll do 2 kilo ohms, and it may still actually go up with the 2200. Nope, it is out of limit. This one looks like it's slightly less, and there you can see a little less than 2000 ohms, 2 kilo ohms right there. We can go to the beige one there, so 1 kilo ohm, like that. So measuring with the meter is really easy there, as long as you stay within the limit. So now here you can see that is what's called the schematic symbol for a resistor. And so that's how I'm going to identify components when I make these videos and my main videos. So I'm not going to draw out the exact components all the time or anything. Use these schematic symbols and you connect them together with lines. So those are conductive lines, just like there's conductive metal under here and conductive metal in the wires and stuff. So those lines indicate a direct connection with something very highly conductive. This is a commonly used symbol for the meter there. So this one is measuring resistance. Earlier we measured voltage of the power supply, which may be indicated by a battery, as you can see here, but also it can be indicated by VCC. Usually you'll see the voltage they recommend written there, and this is ground, so this is our 0 volt reference point, and then that is the voltage in relationship to it. So we consider this 0 volts, and since my power supply is set to 5 volts, we consider that 5 volts there. So you might see positive 5 volts. So we did measure the voltage, if you remember, and there's a giant resistance in between the two of them. So in one sense, that was what we were measuring. You saw that. And then with the resistor, there was no power applied to it. We just measured it directly with the meter, and we got a result in ohms. Ohms is the unit of resistance, just like volts is the unit in voltage. And then current, you usually see A indicating a multimeter. We'll get to that coming up. Current actually goes through the meter. You have an open spot where you fill that with the meter, and the current that's going through whatever you're measuring also goes through the meter. That's how it measures the current. So current is moving charges. Now we're going to look at measuring current. So as we've been talking about, the resistor, it limits current. We're using it as a current limiting resistor in this video, and it has other uses as well. But in any case, to measure current, you have to put current through the resistor and the meter. So current is the actual moving charges, so kind of like water moving through a pipe and through pumps and whatnot. Electrical current flows through components. So they used to think that it went positive to negative, so that's how we still talk about it and draw things today. So more positive to more negative. In actuality, there's electrons that move negative to positive, and when you study physics, you'll learn more about that. But for basic electronics, you think of positive moving towards negative because just the way we design circuits, it's easy to follow positive to negative. But in any case, we have to put the meter in series with in this case, the resistor. So I got the power on, and we will get the meter. So the current has to go through the meter. That's what that A indicates. It's in series because it goes in from the positive supply through the resistor and then through the meter. That's why they're series. And so we got to set the meter now to the range of current that we want. Also, we're going to have to move the probe. So it's going to be less than 20 milliamps of current. If you're not sure, put it to 200. But I know all of these are going to be less than 20 milliamps. We yank this and put it over there. We'll talk about Ohm's law later on. When you know the voltage and you know the resistance, you'll know the current. You can calculate it. And it won't be 100% spot on, but pretty close. So we got that set, and we got the power on. And now, as we saw before, you got the positive side of the power supply on one side of the resistor. You can see that there. They're all plugged into the positive rail right there. And then we have it just floating over here. That means when you say floating, it's not connected to anything. So we'll zoom back, and I'll raise this up a little bit. We'll slide these down. But in any case, this is the 2200 ohm resistor, and we're going to see that gives us the least current because you can see 2.3 milliamps of current. That is because you're taking the voltage, and based on that voltage across the resistor, so voltage is across, current is through. That's an important thing to remember. And voltage is the potential energy, basically. Your potential amount of current. So higher voltages will probably lead to higher currents. You can taper down that current, though, with resistance. So you can see that there. Now the 1 kilo ohm resistor, the math is going to be easier. We have 5 volts divided by 1000 ohms of resistance. So 5 milliamps is 5 thousandths of an amp. So for each volt, you'll get 1 milliamp, each volt across it. So this is a 510 ohm resistor, basically half the resistance of that one. So we should have actually twice the current. Less resistance, more current. That's the main takeaway. We measure the current like that. And then 220 ohms is a little less than half of this one. So actually, I want to raise the current setting, and that's going to be 200 milliamps. It's not going to be as accurate, but it'll be safer. So we will measure that right there. See what we get. So we got more than 20 milliamps right there. So it's a good thing we set it to the 200 milliamps or less. So that's very important with the autoranging. My other meter, you can measure, I think, up to like 600 milliamps or something, just in the milliamp setting. So you got to pay attention to your meter's limitations. For this one, we wanted to go above 20. We probably won't damage the meter measuring that. Let's give that a try now. Hopefully it beeps. Maybe this is close enough where, there we go. Yeah, it beeped. It's out of the limit. So not a whole lot though, so we probably didn't risk damaging it. Now, we're done measuring current for now, so we will yank this, put it back, and do voltage, because that's safer. You don't want to measure, let's say we want to measure the voltage of a power supply that's whatever, 10 volts or something. And with it set to milliamps of current, you don't want to go like this, because as I said before, the current goes through the meter. And so the resistors are limiting current. If you put it directly to a power supply, whatever current the power supply can provide will go through the meter, and if it's above its setting, it may blow the fuse or may damage the meter. And so it's best just to get it onto voltage when you're done. And here's a little graph that you commonly see. So the 1 kilo ohm resistor is simplest to see. For each volt you put across a 1 kilo ohm resistor, you'll get that amount of current. So 3 volts, 3 milliamps, 4 volts, 4 milliamps. If you use twice the resistance, you'll get half of that. So at 4 volts, you'll get 2 milliamps of current. So there's a direct relationship. It's proportional. It's linear. The more voltage you put across a certain value resistor, the more current you're going to get. And if you graph it in a line, that line will be straight. So now this video is going kind of long, but we already looked at the current is the voltage divided by resistance. That's Ohm's law, and kind of a branch of Ohm's law is seeing how hot the resistor is getting. So that's the power. These are 1/4 watt resistors. They're rated for 0.25 watts. So you take the voltage times the current, voltage in volts, current in amps. That'll give you the power in wattage. But the main takeaway is the resistors are getting hot. So there is the 220 ohm. They're all directly to the rail, by the way. So they all have 5 volts across them. So that's the 220 ohm resistor. 510, that's the 1 kilo ohm. And it kind of goes by the hottest element you see and the coolest. So if I zoom in, it'll look warmer, as you can see there. But in any case, you can see the 220 ohm, see if I can get my finger there, is a whole lot hotter than the other ones, because it has a lot more current going through it than the other resistors. So it's voltage times current. Larger resistors would dissipate the heat better, and they would have a higher wattage rating. So you got to make sure you don't put too much power through the component. The power supply here, you can see I had to up how much minimum current I had going through here, because you can see here we got about 40 milliamps of current. So this is not exact, but it's pretty close. It may be a couple milliamps off, maybe 38 or 42 if we measured with the multimeter. But in any case, normally, there's the voltage. Normally I set current to about 30 milliamps. Depends on what I expect to be doing. Oh, I gotta hit that button. But as you can see here, if we lower below 40 milliamps of current, because that's what these resistors demand, you can see that the voltage dropped. And so we are at 30 milliamps right now. We set that as a maximum. So it has to lower a voltage to lower the current through the resistors in order to keep that current down. And down here, I did the math for a 1 kilo ohm resistor. So normally, when you have a component on the schematic, it will give you the value. And they generally assume, when it comes to resistors, that they're 1/4 watt resistors. So if you have 1/4 watt resistors, you see a value on there. Unless it also shows a wattage rating, it's probably safe to use these, almost certainly. But in any case, you can see I got, with a 5 volt power supply, a 1000 ohm resistor will have 5 milliamps and 10 milliamps. I'll fix that before I put it on the diagram. But it'll have 5 milliamps of current, So 5 milliamps of current times 5 volts is 0.025 watts. That's really far from the quarter watt right there. And also, when they're quarter watt resistors, you actually want to keep them closer to 1/8 of a watt, hopefully under 1/8 of a watt. Another thing to notice though, if you double the voltage across a resistor, it will actually be 4 times the wattage. And so it's not linear. If you put 10 volts across a 1000 ohm resistor, it'll be 10 milliamps, not 100 milliamps. But 10 milliamps times 10 volts is 0.1 watts. As you can see, the wattage is 4 times as high. So with if we raise the voltage, that would be too much for a 220 ohm resistor. This is about the minimum you want with 5 volts across it. And the 510 ohm resistor, you could probably get about 10 volts across it, somewhere around there. With the 1 kilo ohm resistor, I think it's somewhere like 13 or something before you start exceeding that 1/8 of a watt. And we will cover this in more detail most certainly in the next video. But you don't just really use resistors. As we saw, they create heat, but usually that's something that you don't like. You limit current. In this case, we have an LED. We can't put it directly across 5 volts. It will burn out. It will allow a lot of current through it. And it should only have about 20 milliamps of current through it. So I have the 1 kilo ohm resistor here. We have the power supply set to 5 volts. And so there will be no more than 5 milliamps of current. Now, one thing to be aware of though is that when you put components in series, they actually split up the voltage, and the LED actually blocks a pretty certain amount of voltage. So first off, the LED is what's called forward bias right now. The long lead, the anode, that's that side, goes to the positive side of the power supply. The short lead, the cathode, goes over there. So right now, this is the current that's going through the jumper, which is the same as going through the LED and the resistor. So, in any case, we plug it back in. We're going to measure voltage first. And so we're going to measure that across the resistor because it is setting the current. As we saw, based on the current going voltage across it, there will be a certain amount of current. So I can go to the negative rail there with the black one, positive there, and we'll see we got 5 volts at the rails. So I'm over there with that one. Now we go directly across the resistor, and it's got about 3.2 volts approximately. And we can measure the voltage. The rest of the voltage is being blocked by the LED, and this is pretty standard for a red LED, about 1.9 volts. So you can estimate that ahead of time. 5 volts subtract a little less than 2 volts. It's going to be a little more than 3 volts across the resistor. And so we will quickly measure the current. So we're going to yank the jumper, and we have to complete the circuit through the meter. And so it's less than 20 milliamps, more than 2 milliamps. We know that. So we'll go to 20 milliamps and move this over here. So normally I'll use the meter that auto ranges, goes a lot quicker. But if you're not used to using meters, it's good to be shown how to use one that doesn't auto range. So we have to make sure we limit the current, and so we got a positive through a resistor that limits current. So we know that. And there you can see we got that voltage across the resistance. Since it's a 1 kilo ohm resistor, we take the voltage divided by 1000, and that gives us our current in amps, which we turn into milliamps. So 0.00316 amps is the same as 3.16 milliamps right there. So that's really it for this video. It went a lot longer than I thought it would, but that's okay. Hopefully you enjoyed it. Hopefully everybody sticks around and watches the whole thing, because I'm not going to cover this stuff in great detail after I already covered it in one of the videos. And so I wrote down here some notes I wanted to cover. We talked about Ohm's law. So for current, that's voltage divided by resistance. There's also the variation find voltage, which is current times resistance, or if you happen to know the voltage and the current, but you don't know the resistance, then resistance is voltage divided by current. And power has a bunch of other formulas too. But in any case, we lit an LED. We saw the LED drops about 1.9 volts. Well, it's forward bias, well, it's connected in the right direction. It actually blocks a lot more if you put it in backwards. So it will not light up if you put it in backwards. So first, let's light it up again. So it's a diode. It conducts in one direction only, really. So there's other rules for diodes, but that's the main takeaway. So if I put it in backwards, I'm wiring it the same way. Now it's blocking more voltage than 5 volts, so it will not light up. That's the basic property of a diode. A regular diode, rectifier diode, does not have those arrows, and it's better at rectifying, blocking in one direction and passing in the other. But the purpose of the LED, it's a diode, but it's one that produces light you can see, and so that's why we use it so much. You can see the light, so that's why I wrote observations here. One of the things you do when you're working at circuits, you see the LEDs light up or whatnot. Maybe a motor turn. There's different observations you can make. You can't see the heat of the resistor unless you have a thermal camera. That's why I really like thermal cameras. You can find a lot of problems in circuits with the observation. If you have a thermal camera, you can see what's getting hotter than you expect. And so theory, we talked about Ohm's law, the current going stuff. I talked about electron flow a little bit. So that's all more intense study that really isn't too terribly needed for building circuits. This is mostly going to be on the building circuits because theory is better reading and diagrams and stuff. It's not as good for videos. A lot of people do make heavily theory videos, but I try not to. I try to do more of the building circuits. So that is it for this video, and the later videos will actually be circuits that do something interesting. They aren't going to be this bland, but you have to understand the current limiting resistor to understand those circuits. So I'll be able to skip all that stuff and get right to the fun stuff that it does, our observation. But these first couple videos, maybe first few videos, will be kind of bland like this, but they're important topics. The resistor is probably the most important topic to understand in great detail to make learning electronics easy. So hope you enjoyed. Thanks for watching. I'll see you in the next video.